Ocean acidification, what it is and what it means for our ocean's future. What is ocean acidification? Ocean acidification is a growing concern for all marine ecosystems in Earth's oceans. The term ocean acidification refers to how the ocean's pH is decreasing due to the levels of carbon dioxide that are being released due to human activity, such as burning fossil fuels. In 2023, the global average of CO2 in the atmosphere was 421 moles parts per million, the highest concentration of CO2 recorded, demonstrating how there was more CO2 in the atmosphere than ever before. Then, approximately 30% of all CO2 in the atmosphere is dissolved in seawater, where the CO2 then reacts with H2O to form carbonic acid, H2CO3, which in large amounts will overcome the ocean's buffering effect and cause a decrease in the pH. As demonstrated by the graph to the right of the screen, the amount of atmospheric CO2 is inversely related to this pH of seawater. Today, the ocean's pH has dropped from 8.2 to 8.1 since the Industrial Revolution and is expected to decrease by another 0.3 to 0.4 pH units by 2100. The role of geology. Understanding the role of geology in ocean acidification is necessary in order to slow its effects. This is because soil and rocks both play an instrumental role in protecting the ocean against additional pH increases. Every year, the rivers on Earth naturally add approximately 500 million tons of dissolved calcium back into the oceans, which will then buffer the acidity of carbonic acid. The calcium ions buffer against the rising ocean acidity by reacting with the excess hydrogen ions in seawater, thereby neutralizing them. This neutralization prevents an increase in pH, as pH is the measurement of the concentration of free hydrogen ions in a solution. So, by reducing the amount of hydrogen ions present in the ocean, the rising acidity is buffered. Soils also play an essential role in ocean acidification, as mineral weathering is naturally accelerated in soils through physical processes such as freezing and thawing, and biochemical processes such as respiration. Geologists are also able to study the potential effects of ocean acidification through extracting deep sea cores and studying the layers of rock from when conditions were similar around 55 million years ago. Effects on marine life. All biochemical reactions that are essential for life are sensitive to small changes in pH levels. Therefore, a small change in the pH of seawater can have large effects on marine life, especially because of the short time span over which these changes are happening. Issues for marine life are already arising. For example, the higher concentration of hydrogen ions in the seawater is causing shelled organisms to struggle in building their skeletons, taking energy away from other important functions such as reproduction. Rising acidification will also limit coral growth from the lack of available calcium carbonate. Existing coral structures will also be eroded due to the increasing acidity. One estimation predicts that by 2080, the ocean will be so acidic that coral will not be able to rebuild as fast as erosion occurs. Thank you.